right? Actually we completed preparations and chemical properties, but this is a special method, okay, and very useful in the aryl halides topic, right? Okay. Actually I given this method as the first method in our PDF, right? Alkanes when treated with halogens in the presence of sunlight, they will produce alkyl halides. Alkyl halides. We completed preparation from alkenes, we completed preparation from alkynes, alcohols, carboxylic acid. Similarly, another like miscellaneous topic, preparation of alkyl halides from alkanes, right? This is called halogenation of alkanes. Halogenation of alkanes means addition of halogen to alkane. See, we are taking two halogens, right? Two Cl2s or two Br2s. One Cl will attach to the R and H will come out. That H will combine with another X, eliminated as HX. Let us see one example. CH4 plus Cl2 gives rise to CH3Cl and byproduct is HCl. Here four hydrogens. We have four hydrogens, right? Remove one hydrogen and add one chlorine. Remove one hydrogen, add one chlorine. Okay, CH3Cl. One hydrogen is coming out. That hydrogen and here one chlorine remains now. We took two chlorines. One chlorine is coming and attaching to CH3 and one hydrogen is coming out. So HCl is formed. CH3Cl and HCl. Okay, right. Let us see the important questions, model questions on this halogenation of alkanes. Clear? Right. Did you get this simple mechanism? Any doubt in this? Very easy. Take alkane, remove one hydrogen and attach halogen. Take alkane, any alkane. You can take ethane also. You can take ethane and add halogen, chlorine. CH3, CH2Cl and byproduct is HCl. One halogen attaches to alkyl part. One hydrogen will comes out. That hydrogen combined with another halogen, eliminated as HCl. Clear? Very simple. Remove hydrogen from the alkane and attach halogen. Very simple, right? Now let us see how questions will come on this. Expected questions, right? Now see one small topic, monohalogenation. Monohalogenation means removing hydrogen, one hydrogen at a time and attaching one halogen at a time. This is called monohalogenation. For example, look at this. I have 6 hydrogen atoms, right? 6 hydrogens, but I have to remove only one hydrogen and I have to attach only one chlorine. That is called as monohalogenation. I'll write the definition of monohalogenation. Removing one hydrogen and attaching one halogen atom. This is called monohalogenation. Right. From actually this is preparation of alkyl halide only, but see how questions will come. Questions related to isomerism. How they link questions to isomerism, let us see. Actually we are doing preparations of alkyl halides only. We did several methods. This is also one important method, halogenation. But how questions will come? See, link it to the isomerism. Let us see. Propane upon monohalogenation produce how many alkyl halides? Cl2H. Propane upon monohalogenation produce how many alkyl halides? How many alkyl halides can be prepared when propane subjected to monohalogenation? Look at this. Remove this hydrogen, primary hydrogen. This is primary hydrogen, this is secondary hydrogen. First remove this hydrogen. Okay, CH3 CH2, CH2Cl. Right? Terminal hydrogen is removed and hydrogen is attached. One possibility. Next, remove secondary. This is primary hydrogen, right? This is secondary hydrogen. Remove secondary hydrogen and attach halogen. First, what we did, we removed primary hydrogen and we attached halogen. Then we got one product. What is its name? 1-chloropropane. 1-chloropropane. This is secondary hydrogen. Remove secondary hydrogen and attach halogen. This is another product. This is 2-chloropropane. This is 1-chloropropane. If I remove this one, what happens? If I remove this one, what happens? I will get a same product like this. Clear? Correct only now? If I remove this hydrogen, I will get 1-chloropropane only now, because I have to give the numbering from this side. If I remove this one or this one, means two terminal hydrogens, I will get the same product. Clear? So propane upon monohalogenation is producing how many alkyl halides? How many alkyl halides? 1 plus 1. Total how many? 2 alkyl halides are producing. Clear? Surabhi? Aisha? Obed? Murali? Who is Murali? Bhakti, you only? Yeah, okay. Vaishnavi? Sadh, everybody. Yeah. See, this is very important model question. Very important model question. Next. Methyl cyclohexane. Methyl cyclohexane upon monohalogenation produce how many alkyl halides? Methyl cyclohexane upon monohalogenation produce how many alkyl halides? See this. First of all, we have to see how many different hydrogens we have. How many different hydrogens we have. Look at this, all of you. Here methyl group is there. No? This hydrogen, I am removing this hydrogen, so I will get one product, right? If I remove this methyl hydrogen, and here also one hydrogen is there, no? Here one hydrogen is present, so removal of this hydrogen gives one product. Next, here one hydrogen is present, 3 degree hydrogen, so I am removing this also. Then what I will get? Methyl. This is another product, right? Here one hydrogen is there. Here one hydrogen is there. I am removing that hydrogen. Okay. Here one hydrogen. We can remove here one hydrogen. Then next, here one hydrogen is present, we can remove this hydrogen also. Monohalogenation means at a time you have to remove one hydrogen, clear? And you have to place halogen, CH3Cl. So count total how many alkyl halides are producing. How many alkyl halides are producing? 1, 2, 3, 4, 5. 5 alkyl halides are producing. 5 different alkyl halides are producing. What happens when we remove hydrogen from this star marked carbon? We will get same. These two are same only. No? If we remove hydrogen from this area, we will get same compound. So you should not remove H from this. Similarly, if we remove hydrogen from this area and this area, we will get same. Clear? So how many different alkyl halides are producing? 5 alkyl halides are producing. This is very important topic. Did you get everyone? Any doubt in this topic? Ayesha, Surabhi. Right. And see, I'm giving one special name for these five compounds. These are structural isomers. These are structural. What we did up to now, we calculated structural isomers. How many structural isomers are formed? How many structural isomers are formed? See, previous also, you can add the question like this. How many structural isomers are formed when propane is subjected to monohalogenation? Very, very important. In second year, isomerism related questions will come, nomenclature related questions will come. This concept is applicable for structural. When you get the question, how many structural isomers are produced when propane is subjected to monohalogenation? How many structural isomeric alkyl halides are produced? Say, structural means apply this procedure, what we did. Do this one. Clear, everybody? Srujan, tell me. Which fourth on this one? 1, 2, 3, 4. Okay. You are saying these two. What is its name? What is fourth compound IUPAC name? What is fourth compound IUPAC name? Is your doubt clear? See, that only I am saying. Why you are saying para position? Will we apply para ortho positions here? Will we apply para ortho? Is this benzene ring? This is not benzene ring. Okay. We cannot say para ortho. This is cyclohexane ring. We use para ortho meta words for benzene. Ortho disubstituted, meta disubstituted benzene. Clear? Okay. Your doubt is cleared or not? What is your doubt? Clarified or not? What I am asking, give its name. What is the name of fourth compound? What is the name of fourth compound? What is the name of fourth compound? One, two, three, four, five, six. 1-chloro-3-methyl cyclohexane. 1-chloro-3-methyl cyclohexane. Fourth compound IUPAC name. Fifth compound IUPAC name. 1, 2, 3, 4, 5, 6. 1-chloro-4-methyl cyclohexane. 1-methyl-4-chloro. 1-chloro-4-methyl. 1-chloro-3-methyl. IUPAC names are different, so different compounds. Whenever you get the doubt, for example, you are having some doubt whether these two are same or these two are same, then do one thing, give IUPAC names. If you get two different IUPAC names, then compounds are different. If you get same IUPAC names, then compounds are same. Clear? This is 1-chloro-3-methyl cyclohexane. This is 1-chloro-4-methyl cyclohexane. Clear? Others, Surabhi, did you get this? Bhakti, ఈ టాపిక్ ఏమైనా డౌట్ ఉందా మీకు? Right, you do this question. Srujan, are you there? How many structural isomers are produced when 2-methyl-butane, very important example, 2-methyl-butane is subjected to monohalogenation. 2-methyl-butane. Try, everyone, try and say the answer. Obaid and Saad. Are you there, Obaid and Saad? How many different alkyl halides are produced? Structurally isomeric alkyl halides. See, I didn't enter into optical. I am explaining structural only. Clear? Optical also there. Optical concept also there. How many different alkyl halides are produced? Aisha? 4. Right. Look at this. 4 is the answer. Look at this, all of you. Surabhi, Aisha, all of you, look at this. Remove this hydrogen and attach halogen. CH3, CH, CH3, CH2, CH2Cl. One compound. This is one compound. Right? We remove this hydrogen. Remove this hydrogen and attach halogen. That is another possibility. Clear? Right. CH3, CH, CH3. We remove this hydrogen. Another possibility, here one hydrogen is there now. Remove this hydrogen. CH3, C, CH3. This hydrogen. This is another one. Next possibility, remove this hydrogen and put halogen. Remove hydrogen. Okay. CH2Cl, CH, CH3, CH2CH3. Some people will get doubt. Sir, why cannot we remove hydrogen from this? If you remove hydrogen from this, you will get a same compound similar to this. I'll show you why. If I get same compound, if I remove hydrogen from this area, see, I'm removing, just a second. I'm removing hydrogen from this methyl group. CH3, CH, CH2Cl. Okay. Clear. Now, its IUPAC name, its IUPAC name, its IUPAC name is different, right? These are having different IUPAC names. And give its name, give the numbering. 1, 2, 3, 4. Correct only na? What is its name? 1-chloro, 2-methyl. See, this is bute. 1-chloro, 2-methyl butane. What is its name? 1-chloro, 2-methyl butane. 1-chloro, 2-methyl butane. 1-chloro, 2-methyl butane. Next, its name, its IUPAC name. Select the longest chain. This is the longest chain now. Right? 1, 2, 3, 4. You should have some idea about nomenclature. 1, 2, 3, 4. 1-chloro, 2-methyl butane. Same name. 1-chloro, 2-methyl butane. 1-chloro, 2-methyl butane. So these two are same. So one, and this is one only. Consider these two as one only. Clear? So how many? 4. 4 is the correct answer. Very important question. This is a multi-conceptual question. This question can be used in alkanes chapter. This question can be used in alkyl halides chapter also. How many alkyl halides are produced? How many? 4 alkyl halides are produced. You will get question. You may get question coming exam, your Monday exam. How many alkyl halides are produced when 2-methyl butane is subjected to monohalogenation? 4 alkyl halides are produced. Okay, preparation methods are there now. So you may get this question. How many alkyl halides can be prepared upon monohalogenation of 2-methyl butane? They won't give the structure also. You have to draw 2-methyl butane structure. Clear, all of you? How many structural isomers? In isomerism chapter, how question will come in first year isomerism? How many structural isomers are produced? Concept is same only, question will different. Question is different. Clear? How many structural isomers are produced? In second year, how we will get this question? How many alkyl halides are produced? Single concept with 2 different framings. Right? Got it? Surabhi, ఫాలో అవుతున్నారా? ఏమైనా డౌట్ ఉందా? ఆయేషా, వాట్ అబౌట్ యూ? భక్తి, భక్తి, భక్తి. Boys, what about you? Saad, Obed. Saad and Obed. Right. Good. Now, yes, tell me. I see different types of hydrogens only. Correct only. I have taken different types of hydrogens only. No? Okay, this hydrogen same, but this hydrogen both are different. No? This is primary only, but this environment is different. This methyl is connected to CH2. Environment is different. No? This methyl is connected to CH2. This methyl is connected to CH. Environment is different. I given this sentence also. If you get a doubt, for example, you are having doubt between these two, then give the name. Primarily we have to take different hydrogens only, but finally what we take into consideration, names, IUPAC names, 4 different names of 4 different products. Clear? Basic idea is number of different hydrogens only. Clear? According to that concept, that is also correct. This is different types of environmental hydrogen, because this methyl is connected to CH2, but this methyl is connected to CH. Environment is different. Surrounding environment is different. Okay, right. Now let us enter into optical. How many optically active alkyl halides are produced upon monohalogenation of butane? Clear? Note down a very important model question. How many? Let us do one thing. Total isomers, right? Total means including optical also. This is best. Clear? Optical means again we have to eliminate that structural. Let us do directly. How many total isomers are produced? Total isomers. How many total isomers are produced? Total isomers means you have to consider optical also. How many total isomers are produced upon monohalogenation of butane? Upon monohalogenation of butane, how many total alkyl halides? Total alkyl halides means optically reactive alkyl halides also. Okay, total isomers. You have to include optical also. I'll explain one question, then you will do another one. First of all, look at this. All of you, stop writing and listen first. Okay? I'm taking butane. CH3, CH2, CH2, CH3. Okay. I'm doing monohalogenation. Cl2, Cl2H now. Okay, write directly. Again, why we have to write Cl here? I'm writing directly. I'm removing this hydrogen. CH3, CH2, CH2. See, this carbon is having 3 hydrogens. I'm removing one hydrogen and placing one halogen. So CH2, Cl. This is one product. Can I write one here? One. Oh, sorry. One. Correct. Can we remove this hydrogen? Secondary hydrogen. This one. Secondary hydrogen. This is another possibility, right? Can I remove this hydrogen? Please respond. Can I remove this hydrogen? Can I remove this? Can I remove this? Bhakti? Can I remove this hydrogen? Surabhi, can I remove this? Why? Why? This one and this one both are same. I cannot remove this also. So these are the possible structures. Now we are doing total. We are doing total isomers, right? After removing this hydrogen, did we get any chiral center here? Did we get any chiral carbon? In this, any chiral center is present. Is there any chiral center in this? No, chiral centers are 0. Chiral center means carbon which is surrounded by 4 different atoms or groups. Chiral centers are 0. Now, when we remove secondary hydrogen, see, chiral center is formed. This is chiral center. Chiral center means the carbon which is surrounded by 1, 2, 3, 4. 4 different groups. Carbon which is surrounded by 4 different groups. Middle carbon which is surrounded by H, one atom, CH3, another one, chlorine, another one. This total ethyl group is 1. So chiral center. How many chiral centers are there in this compound? 1 chiral center. Then what is the formula to find the number of optical isomers? 2 to the power n. How many chiral centers are there? 1. So 2 to the power 1, 2. So here 2 compounds and here 1. Here 1. 1 plus 2. Total how many? 3 compounds are forming. 3 total isomers are forming. In that 2 are optically active and 1 is normal. 2 optically active alkyl halides and 1 is normal alkyl halide. Total 3. How many optically active alkyl halides are produced? 2 optically active alkyl halides. This is the formula. Number of optically active compounds 2 to the power n, where n is equal to number of chiral center. 2 optically active compounds and 1 normal compound. Total 3. Got it now, all of you? Any doubt? Clear? Right. Let us see the mechanism. Mechanism of halogenation of alkanes. Let us take one example. CH4 plus Cl2. H nu gives rise to CH3Cl plus HCl. Step 1, chain initiation. These steps will come in the exam. Chain initiation step. Chain initiation. In chain initiation, halogen molecule undergoes homolytic cleavage. Homolytic cleavage means, look at this, all of you. In the bond, 2 electrons are present in any bond. For example, if we consider this is a bond, at this end 1 electron, at this end 1 electron is present. Okay, and this is 1 atom, this is 1 atom. Homolytic means 2 bonded atoms will get 1 electron after cleavage. The bonded electrons are equally shared by the bonded atoms. So we will get Cl dot and Cl dot. Chlorine free radical is formed. How you will get the question? Which of the following is the chain initiation step? Which of the following is the chain termination, chain propagation step in the halogenation of alkenes? That is the question. Okay. Chain initiation step is clear for everyone. In chain initiation step, what happens? Halogen molecule undergoes homolytic cleavage and halogen free radical is produced. Any doubt in this? All of you. Next. Step 2. Chain propagation. chain propagation. Chain propagation. Again, chain propagation is classified into two steps: propagation 1 and propagation 2. Chain propagation. Chain propagation 1. See, in chain propagation 1, the formed halogen radical react with the methane. See, I am writing methane like this: CH3H. Methane, CH4 can be written as CH3H. The formed halogen radical, any one radical reacts with methane. See, this radical enhances or encourages this carbon hydrogen bond to cleave homolytically. What is the driving force why this bond is cleaving homolytically? Because of this radical. This radical is encouraging this bond to cleave homolytically. Clear? In the propagation step 1, the formed halogen radical in the initiation step combines with methane, reacts with methane. Then carbon hydrogen bond in the methane undergo homolytic cleavage, leads to the formation of methyl radical. See, this methyl is getting one dot, one electron. See, H dot and Cl dot. What we will get? H dot and Cl dot. Tell me what we will get. HCl. H dot and Cl dot. HCl is power. This is propagation 1. Okay. Next. Propagation 2. In propagation 2, the formed methyl radical reacts with halogen molecule. You have to do practice these steps. There is no logic in this, just practicing only. The formed methyl radical reacts with a halogen molecule. Right? In halogen, Cl bond is there. Now this bond will undergo homolytic cleavage. Cl dot methyl dot, both will combine to form methyl chloride, our required product. Methyl chloride and Cl dot is formed again. Cl dot. Methyl chloride and Cl dot. Methyl chloride is formed. Alkyl chloride is produced or not? Right? So these two are very important. First step is easy only. How you will get? Which of the following is not the propagation step? Which of the following is the propagation step? Like that questions you will get. Clear? This is practicing only. There is we can use in propagation 2. No, not like that. In propagation 2, halogen radical will generate chlorine radical. Okay, you will get chlorine radical in the initiation step only. Clear? Later, what is the source of chlorine radical? This alkyl radical. This alkyl radical will produce chlorine radical. Very important question, but in the chain initiation, once radical is formed, once after utilization of radical, again what is the source of halogen radical? Methyl radical. Methyl radical will generate halogen radical. That's why I said. Clear? So you will get confusion. If you do not do practice, you will get confusion. Right? Initiation, propagation. Next, termination. Chain termination. Chain termination step. In chain termination step, all the possibilities like halogen radical will combine with halogen radical, CH3 will combine with Cl radical, all types of combinations will take place and the reaction will end. All the possibilities. Right? Others? Bhakti, Surabhi, Aisha, are you getting? Surabhi? Follow up the Nara Surabhi Meru. Right, next. Once look at this, all of you. What is our main reaction? We are doing preparations of alkyl halides from alkanes, right? Preparations of alkyl halide. What is X here? Tell me, what is X? What is X? X is halogen. Fluorine, chlorine, bromine, iodine, right? Clear? Right. If I take Cl2 here, what I will get? RCl, alkyl chloride is produced. If I take Br2, alkyl bromide is produced. Alkyl bromide is produced. Now my question is, can I prepare alkyl fluoride in this method? Can I prepare alkyl fluoride? Srujan, can I prepare alkyl fluoride by taking F2 here? Why? For leaving. Requires lot of energy. Requires lot of energy. Can I prepare iodoalkane? Surabhi, can I write Ri here? Can I take I2 here? Can I get Ri, alkyl iodide? Saad and Ubaid. That only the reason, right? Look at this, all of you. See, alkane when treated with X2 will get alkyl halide and byproduct is HX. The order of reactivity of halogens towards alkanes, fluorine is greater than, bromine is greater than iodine. This is order of reactivity of halogens towards alkanes. Means when you take alkane and add fluorine, it reacts immediately and produce alkyl halide. When you take alkane in one beaker and add fluorine and you keep under sunlight, you will get alkyl fluoride spontaneously, instantaneously, right? After that, when you add iodine to alkane, take alkane in one beaker. Your aim is to prepare alkyl halide, right? For that, you are taking alkane in the one beaker and you are adding iodine and you are mixing and you are keeping under sunlight. But the reaction takes place very slowly, very slowly. It takes days, months also, right? So alkyl iodide preparation from this method, halogenation, is not preferred because it is a very slow process. And another important reason also there, I'll tell you. And fluorides, why this method is not preferable to prepare alkyl fluorides, methyl fluoride, ethyl fluoride. You can ask, sir, if you take F2 here, we will get RF, we can prepare, but we cannot. This method is not suggested for the preparation of alkyl fluorides. Why? Look at this reactivity order, which is highly reactive towards alkane, fluorine, highly reactive, highly exothermic. This is very, very important. This reason you have to say highly exothermic, highly exothermic. See, I'll tell you, your aim is to prepare alkyl fluoride. For that, you took methane in one beaker and you added fluorine gas to it, and you kept this total equipment under sunlight. Then what happens? It will burst. Means it is a highly exothermic. Large amount of flame is produced and this test tube will break. Total contents will fall down. Then how can you collect the product? Product formation takes place only along with that large amount of flame is generated. Then how? If large amount of flame is created in the lab, can you prefer that method? No, because flame catches other things also catches the fire, right? So this is not suggestible. Okay, reaction is very fast. How much fast? So that it can catch the fire. Clear? Reaction with the fluorine is highly exothermic. That is the reason. That's why this halogenation method is not suggested for the preparation of alkyl fluorides. That is the reason. Because reaction with the fluorine is highly exothermic. That word is important. Highly exothermic. Not suitable for the common laboratory conditions. Right? Okay. Next, why it is difficult to prepare alkyl iodides? I said one thing, very slow, because reactivity of iodine is very slow. Okay, along with that, another reason also there. See, I'm trying to prepare alkyl iodide by using that halogenation method. I'm getting alkyl iodide and HI, hydrogen iodide. What is the byproduct? Byproduct in the previous reactions, HX, means HCl or HBr or HI. Here what is the byproduct? HI. HI is a good reducing agent. HI is a good reducing agent. Good reducing agent. This reducing agent reduces methyl iodide back to methane. Reverse reaction takes place. Actually, your aim is to prepare methyl iodide. So you got methyl iodide and you got byproduct also. What is that byproduct? HI, hydrogen iodide. It is a good reducing agent. Reduces formed product back to reactant. So this is also another reason. Actually, this is a slow reaction, very slow reaction. And another one is the formed byproduct HI is a good reducing agent. It reduces formed alkyl iodide back to alkene. Clear? That's why this reaction is carried in the presence of oxidizing agents. That oxidizing agent remove HI, HNO3. In the presence of HNO3, we will carry this reaction. Then we can prepare. Why? That HNO3 oxidizing agent removes this HI time to time, and we will get CH3I. Clear? Right. So then which method is preferred to prepare alkyl iodides and alkyl fluorides? Special methods are adopted. Why we are not using this halogenation technique? Because if we do fluorination, that is highly exothermic. If we do iodination, that is very slow, and formed byproduct is good reducing agent. That's why special methods are adopted. Finkelstein and Schwarz reactions. Number of times these two questions came in the NEET exam and JEE Mains exam and other objective exams, MCET. Clear? So special methods are adapted for iodination and fluorination. Let us write next reaction. Finkelstein reaction. Finkelstein reaction used for iodination. Iodination of alkene. This is also called as halogen exchange reaction. Iodination of alkane. RH stands for alkane. This is also called halogen exchange reaction. Halogen exchange reaction. Halogen exchange reaction. See the definition of Finkelstein reaction. Alkyl chlorides or bromides. Means you can take methyl chloride, methyl bromide. Alkyl chloride or alkyl bromide. Methyl chloride or methyl bromide. When treated with sodium iodide in acetone, dry acetone. Sodium reagent is very, very important. This question will come in the coming exam. Very important. Reagent of Finkelstein is sodium iodide in acetone. Alkyl chloride or alkyl bromide when treated with sodium iodide in acetone. See, this halogen is exchanged by iodine. Look at this. This Cl is or Br is. Okay? Right. Sorry for the interruption. See, this chlorine will be removed and iodine will be substituted. So Ri and byproduct is NaCl. NaCl. Next, this is for iodination. See, one halogen is removed and another halogen is substituted or attached. So this is called halogen exchange reaction. Halogen exchange. Next is Schwarz reaction. Schwarz reaction. Schwarz reaction. Schwarz reaction for fluorination. Fluorination of alkane. Fluorination. This is also halogen exchange reaction. See, same alkyl chlorides or bromides when treated with. Can you say the reagents list? Anybody? Can you share the reagents list? Srijan, can you say the reagent list? Adiva, any idea? Sorry. For fluorination, what we use? NaF. Reagent list. AgF or HgF2 or SbF3 or COF2. Very, very important. Any reagent you can use. AgF, HgF2, SbF3, COF2. We will get an alkyl fluoride. Alkyl fluoride. Schwarz reaction is very, very important. Schwarz reaction is most important. Finkelstein, Schwarz named reactions are very important. Got it, all of you? No one is sounding. What happened to, are you getting other students? Hello? Right. Next.